Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain, and in today's lecture we will study about division algorithm in polynomials. In the previous lectures we have studied about what is a polynomial, like how is it different from an algebraic expression, and then various categories of polynomials based on number of terms like monomial, binomial, trinomial and so on, and also based on the degree of a polynomial. For example, constant polynomial, linear polynomial, quadratic, cubic, etc. Right? We also studied about zero polynomial and how the degree of zero polynomial is not defined. So, in today's lecture, let's start division algorithm in polynomials. Division algorithm in polynomials. First of all, you must be comfortable with real numbers, right? So, let us say if there is a real number, let's take 17 and I divide it by 5, right? How will the division work? I will take 3 here, 15 and then subtract and write 2 here, right? So, if I want to write 17, I can write it as 5 into 3 plus 2, right? This was how division works in real numbers. In this, on the similar lines, we do it in polynomials also, right? For example, if I want to divide a polynomial px by, let us say, another polynomial gx, right? There will be some quotient, right? What will come here? Here you wrote 5 into 3, 15, right? So, here you will write gx into qx, right? And then we will subtract it and we will get certain remainder. Let us say the remainder is rx, right? And what we studied about remainders in real numbers, that the remainder will always be lesser than the divisor, right? Remainder was always lesser than the divisor and it can be greater than or equal to 0. And when was it equal to 0? When the divisor was a factor of the dividend, right? So, in this case p of x is equal to how much? Gx into qx plus rx, right? How did we obtain rx? By subtracting gx into qx from px. What we did was px minus gx into qx, it is equal to r of x. So, if I bring this thing to the right hand side, I will get expression like this. Now, we need to take care that the remainder in the case of polynomials, the degree of this remainder, the degree of remainder is always lesser than the degree of divisor, right? And it can be equal to 0, right? It will be greater than or equal to 0. When will it be equal to 0? When gx is a factor of px, right? Degree of rx will be equal to 0. Not the degree, rx itself will become 0, right? Rx itself will become 0 when gx is a factor of px. Degree of rx 0 means that rx will be some constant, right? So, let us leave this part. Degree of rx is lesser than degree of gx and rx is equal to 0 when gx is a factor of px, right? So, this is the difference that you need to take care of, right? So, the expression that we got is dividend is equal to divisor into quotient plus remainder, right? And degree of remainder is lesser than degree of divisor, right? And remainder can be equal to 0 when the divisor is a factor of dividend, right? For example, if I take certain polynomial like this, x minus 1 into x minus 2, right, and if I divide it by x minus 1, what will be the quotient? Quotient will be x minus 2, right. I will get x minus 1 into x minus 2 here, and it will simply get cancelled, and I will have 0 here, right. So I can say that x minus 1 is a factor of x minus 1 into x minus 2, which is quite obvious also, right. So I will get 0 here when when the divisor is a factor of dividend, right. Otherwise I will get some quotient, I will get some remainder where the degree of this remainder is lesser than the degree of divisor, right. So, and let us say we are given a biquadratic polynomial. We are given a biquadratic polynomial. The method to think about biquadratic polynomial is that it will have 4 zeros, x minus beta, x minus gamma, x minus delta, let us say. This is a biquadratic polynomial. Let us say we are given one of the zeros, right, and we are asked to find out the rest of the zeros. What we will do is, I will divide that biquadratic by the given factor. If a 0 is given, I can easily find the factor. Let us say he says that delta is a 0. So I can say that x minus delta is a factor. Then I will divide the polynomial by that factor, right, and I will get the rest of the polynomial as a quotient, and then I can factorize this to find the remaining zeros.